Okay, this video that comes up here is going to be a tutorial on flowchart proofs. And just a reminder, to do a flowchart proof, you have to have, let's see, what are the ways you could prove two triangles are similar? So either match up a couple of angles, angle similarity, match up three sides and show that they make the same fraction, which is called proportional, or mash up a side, proportional, an angle right next to it, and then the very next side. And those are the three ways you could show two triangles are similar. When I look at these two triangles right here, I don't have any sides, so these two are out. All I could do is maybe angles. So let's see if I have any angles. And before I even start the proof, I would just try to go at some angles. So I know right away that this angle and this angle are exactly the same because they're vertical angles. The other thing I know, because these lines are parallel right here, because these lines are parallel, I know that this angle right here and this angle right here are the same also. And that would be because of alternate interior angles. Okay, so now that you have that the triangles are similar, and you have two angles that you can say that, let's go ahead and write the proof. You have to prove it. So the right formal proof for this, I'm going to start with one reason I know they're similar. The first reason is that angle X is the same thing, congruent to angle and C. And the reason I can say that is because they are alternate interior angles. Now, purists would say that you'd have to have a reason to say that these are alternate interior angles, and you'd have to write out that you know that these two lines are parallel. Well, you know they're parallel. It's a given. I don't think you need that step. It's already given. Just not waste a bunch of time writing out the given. So that's true because alternate interior angles. The next thing I know, and I have to be careful because there's confusion as to what angle is angle Y. You can't call any of these angles angle Y because there's confusion. Which one is it? So I want to make sure that I'm looking at angle X, Y, B, and that will be the exact same as angle A, Y, C. And the reason those are the same is because they are vertical angles. So each time you make a statement, you have to say why you know that statement is true. So there we go. I know why the statement is true here. I know why the statement is true there. Therefore, I know that the triangles are similar. And I will label the first one triangle X, Y, B. Now, once you label the first one, you have to be careful how you label the second one. So angle X must go with angle C. So I must start with C. Angle Y must go with angle, well, Y. It's one of my Y angles, huh? And then the last one would be A, because B and A match up. So, and the reason I know that these two triangles are similar is angle similarity. This is a flowchart proof because it flows from this point right here down to there. This is one reason, and from this point here down to there. So the reason that gives me those two angles are congruent gives me that one condition for being similar triangles. The reason I have these two angles are congruent is the second condition that these triangles are similar, and there you go. Let's try another. So the next one, I want to prove that these two triangles are similar. So I don't know. They're similar. First thing I notice right off the bat, though, in these two triangles, this little triangle and this big triangle, is that this side, this angle, not a side, this angle right here, is exactly the same angle in both. I could take them apart and put this little triangle over on the side, but this angle is the exact same angle in both. There it is. So there's one angle that matches up. Can I do angle similarity? Well, I'd need another angle. If I only knew these two lines were parallel, then I could maybe say something about those angles. But I don't know those lines are parallel. So I can't do angle similarity. I'm really confused. I don't see why I could use any other angles. Could I use side similarity? And again, there's one side here I know nothing about. And I don't know anything about this side either. So it's not a right triangle. I could find out. So I can't use side similarity. Could I use side angle side similarity? Well, there's an option. I just have to show that one side is proportional and the other side makes the same fraction, and this angle in between is the same. Well, I got an angle in between. So this little side right here is 4, and the big side of the big triangle right here is 8. Agree? This little side here is 5, but the big side of this big triangle is 10. Well, that's beautiful, because I know that the measure of AB, the length of AB, divided by the length of AC, the big triangle, right, is the same thing as 4 over 8, which is 1/2. Okay, and how do I know this? Did I have to figure anything out? No, all the values were given, so I'm just going to write that given. That is boring, but sometimes boring is nice, huh? The next side I know, well, let's do the angle. I know angle A, well, it's the exact same thing as angle A, isn't it? And that's because it's the same angle. Same angle. That's kind of boring too. Oh well. And then the last one, on this other side, I have that side AE over side AD is the same thing as 5 over 10, which gives me 1/2. 1/2, proportional. So both sides have the same fraction. The angle in between is exactly the same. I have side angle side similarity. These two triangles are similar. So triangle, let's call it ABE, is that all right? ABE. The first one's not bad. It's similar to triangle. Now the second one, I have to be careful. So the angles have to match up. So if A is first, A has to be first on the second one. And I believe it goes angle ACD. And that matches up with the first one. And this is because of whoops, screwing up there. Side angle side similarity. So there we go. This leads to that, this leads to that, and this leads to that. One more. Now this one, my 3 ways. Angle, angle, similarity. I know one angle in both triangles, so can't use that. Side, angle, side similarity. I could use that. I could use that. I know side, angle, side. I have them right there in both triangles. But I don't want to use that. So I don't suggest you do that, but in this case, I want to use side, side, side similarity. And I can, because the beauty of this is a right triangle. 6 and 8 are legs, and 6 squared plus 8 squared, so 36 plus 64 gives me 100. This side here would just be 10, using Pythagorean's theorem. And this side is 3, this side is 4, so using Pythagorean's again, I will end up with this side being 5. So do they all make the same fraction? Well, I'm pretty sure 3, what do you want to go? Big to small or small to big? However you want to make your fraction. Let's go big to small. 6 divided by 3, 2. 8 divided by 4, 2. 10 divided by 5, 2. I know all 3 sides, they match up. I have side, side, side similarity. All I have to do is write out the proof. So AC over DG is the same thing as 6 divided by 3. I can't write very well, which equals 2. And how do I know this? Do I have to calculate anything? No. Everything was just given to me. So I write given. The next sign I have is AT over GO. And that would be the same as 8 over 4, which is 2. And again, just give it to me. Then the last side, I have CT over DO, and that's the same thing as 10 over 5, which gives me 2. Beautiful. Proportional, huh? All the sides make the same fraction. I know this because I used Pythagorean's theorem, so I'm going to abbreviate Pythagorean's theorem. And that's how I got those values. There we go. So to finish up our proof, All we need to say is the two triangles are similar. So I should call the first triangle CAT. Now I must be very careful. CAT is similar to triangle D. D matches with C. That looks about right. D. And G matches with A. Oh, too bad. I thought cat was similar to dog, but not in this case. So I have triangle cat similar to triangle DGO, and that's because of side, side, side similarity. And this is a flowchart proof. This flows to there, and this flows to there, and that flows to there. There you go. That's flowchart proofs in a nutshell. Whatever a nutshell would be with flowcharts in it. Thanks. Try again. Or come again.